Hi, this is a video about multiplying a whole number by a fraction. So that's what we're working on. And so the kids actually have notes in their Blue Spiral notebooks that they took 2 days ago. But in case that doesn't make it home, here's an example of what I'm talking about, a whole number times a fraction. So I've got 2 times 1/8. And so then each part of that problem actually stands for something. It's like directions, giving them directions. So step 1, 2 is the whole number, and it tells you how many rectangles to draw, as well as how many times the fraction gets repeated when you're doing the repeated addition, because their directions say to draw the picture as well as show the problem using repeated addition, because we talked about it in class, and that's what multiplication stands for. Multiplication stands for repeated addition. For instance, 3 times 2 equals 6. You've either got 3 plus 3 being repeated because it's being repeated twice, or you've got 2 plus 2 plus 2, and that's where the 2 times 3 comes from, because 2 is being repeated 3 times with addition symbols in between them. So 2 times 1/8, we're going to get to it as repeated addition in a minute as well. So the 2 is the whole number, is how many rectangles you would draw. Step 2, see, I say step 1, step 2, because step 1 means look at the whole number first, because you can't draw anything till you know how many rectangles you need to draw. So step 1, I always say look at the whole number first. So 2, here's your whole number, that's how many rectangles you have to draw. Step 2, it says to 8, see the 8 in black? 8 is the denominator, and it tells you how many pieces to cut each rectangle. And notice that I underlined each, because it's really important that they understand that this happens to every single rectangle they draw based on that whole number. So the denominator lets you know, so in this case I have 8, so I'm going to need 8 pieces per rectangle, so I'm going to have to cut everything into 8ths. And we talked about it in class. It was hard for them to understand at first, but if I want 8ths or 8 pieces, then I need to make 7 cuts. So you always make 1 less cut than the pieces that you want. And I'm going to show you an easy way to make 8ths so that they don't get all sloppy and everything. And we're still human, so I understand we're not going to be perfect. But there is an easy way to make 4ths and 8ths, because most kids can make halves. So anyways, step 2, look at your denominator. So that's where step 2, my eyes would go to the denominator, the one down below the vinculum, because we talked about that this bar in the fraction is called a vinculum. It's Latin for holding it together, to be a piece of or part of. So 1/8 is one number. It is not 2 separate things. 1/8 is worth 0.125, so 12.5 cents. And that's a number, just like 2. And I missed the 2. See, there's 2. 2 is a number, and we're not going to, consider anything else but 2, just like this is 0.125. So this is a number, not, it's not separated. All right. Then we have step 3. So step 3, 1 is the numerator in this problem. So 1 is the numerator, and it tells you how many to shade in each rectangle. So again, I underline each because it is very important that once you've cut them into pieces, that you shade in each rectangle separately. So the numerator is the last step. Step 3 is the last thing you will look at, and it is what will let you know how many pieces to shade in each rectangle. And then I give a little note saying, remember to use diagonal lines, check mark, yes, the diagonal, see, to shade instead of coloring in. We don't want the big blocks colored in anymore. And it's not because I'm trying to be specific or picky. We're moving on in a few days, and the next thing that we move on to, it requires the shading to be in diagonals, or else it messes up everything. So I'm just trying to prepare them to what they're coming to. So if they would just start practicing shading using diagonals now, it's going to help them in the future. So then let's look at that problem. So 2 times 1/8 looks like this as a picture. 2, step 1. How many rectangles am I drawing? 2. That's my whole number right there. So I'm going to draw 2 rectangles. And again, I'm not perfect. See? Just a human, so... Ta-da! There's my 2 rectangles. Then I look to my denominator. Step 2, look at the denominator. Eighths. I have to cut these into eighths. So here's my little trick about cutting something into eighths or fourths. First, I cut it into halves. So I've got halves. And again, they're not perfect. So see? Halves. If you cut each one of these halves in half, so in other words, half of a half gives you fourths. See that? Now we're not there yet because we're not supposed to have fourths. We're supposed to have eighths because this denominator is an 8, so I need 8 pieces. Right now I only have 4 pieces. So if you cut each fourth in half, in other words, half of a fourth, you'll get eighths. So I'm just going to slice each one of these in half, and again, they're not perfect. My board moved on me, and that first one came out really tiny, but it's okay. Again, we're humans. It's okay to not be perfect. So there, I have eighths. And I double check and be like, 1, 2, 3, 4, 5, 6, 7, 8. Ta-da! 1, 2, 3, 4, 5, 6, 7, 8. Alright, there it is. So I have my eighths cut, and then the last step, step 3, was to look at the numerator. The numerator is the one on top. So I need to shade 1. It only says 1. If it said 2, I would shade 2 in each of these, but it doesn't. It says 1. So I'm going to use my diagonals. And again, look, there's a messed up a little sloppy there, and it's okay, I don't care. So look, there's the picture of what 2 times 1/8 looks like. 2 holes, split into eighths, 1 shaded in each. Then the kids have these directions to say, it says like, show this using repeated addition. So, repeated addition, look at this. I actually have my repeated addition in front of me in a picture as well. 2 times 1/8. 2 lets you know how many times a fraction is repeated. So 1/8 plus 1/8. Wait a minute, isn't that like representing what this picture says? Isn't there 1/8 shaded in that picture? And look, there's also 1/8 shaded in that picture. The repeated addition also represents the picture. So 1/8 plus 1/8, there's my repeated twice. And what does 1/8 plus 1/8 equal? Well, there's a song, and yes, I guess I'll embarrass myself, but we sing some Taylor Swift to remind us when we are adding fractions or subtracting them, which we're not in this case, but when we add or subtract fractions, we sing that we will never, ever, ever add or subtract the denominators, like never. So we keep singing it every time we go to add it so that they remember that eighths, like I said, eighths, that's one thing. It's a number. So when I have eighths and I'm adding eighths, I call it like apples, and I've got apples. I should end up with apples. So my eighths should still be eighths in the end. Now sometimes we do things called reducing, but we're not going to worry about that right now. So if I have eighths, I automatically know that my denominator should be written as an eighth. And then I've got 1/8 plus 1/8. So if I have 1 of something and I add another of it, I always have 2 of that thing, right? So 1/8 plus 1/8 equals 2/8. Because again, we will never, ever, never, ever, never, 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 ever, ever, never, ever, ever, ever add or subtract the denominators. So 2 times 1/8 looks like this as a picture, looks like this as repeated addition, and gives us an answer of 2/8. And the kids, you can ask them, and maybe they might not remember. We'll see. We talked about a pattern that you see. So if we write that problem out, 2 times 1/8 equals 2/8. And they're looking right at that. We talked about a pattern between this problem in that answer. So we talked about something that they could notice. And since they had homework, they had like 4 problems, then they were right underneath each other. So they could see that pattern happening every time. So, you know, you can ask them, what pattern did you talk about? And, you know, what is it? They might not remember because they just talked about it today. So, but you can see if they remember. All right, so that is the long version of it. So they can just make up problems. If you want to practice with them, whatever, you could do something like 3 times 2/5. So now it's changed. It's not a unit fraction anymore. It's called a unit fraction when there's 1 on top. This is not a unit fraction anymore, but it's still the same process. 3, whole number, step 1. Look at that whole number. How many rectangles? 3. So 1. Ooh, horrible rectangle. There. 2. 3. Look at the denominator. Step 2. 5. I need fifths in each one of these. There's no fun way to cut this, and so you just end up having to make 4 cuts. 1, 2, 3, and 4. 1, 2, 3, 4 cuts. 1, 2, 3, 4 cuts gives me 1, 2, 3, 4, 5 pieces. So 1 less cut than what you need. All right, then I go to my numerator. Step 3, last step. It's a 2. So I'm going to shade in 2 in each rectangle, just like I cut each rectangle into fifths. So there's 1, and then some kids already starting to realize, well, hey, I don't need to shade these diagonals over and over again by themselves. If I'm taking out 2, and then I'm just going to go ahead and shade 2 diagonally at the same time, right? So then they are required to write what it looks like in repeated addition. Again, this tells you how many times that gets repeated. So this is 2/5 plus 2/5 plus 2/5. And again, you're going to notice something. This represents that picture. So in essence, couldn't I put a plus sign in between those pictures as well? So then we will never, ever, never, ever, never, ever, never, ever, never, never, ever, never, ever add or subtract those denominators. So fifths should remain fifths. And then I get to go 2 plus 2 is 4 plus 2 is 6. 6/5. And then we talked about this in class as well. We talked about Miss Turner had this as an answer. She actually had the word or, which is the equals works there too. But anyways, Miss Turner had or 1 and 1/5. So we had a discussion in class what that means. It means that 6/5 is greater than 1 whole. It's called an improper fraction. Improper fractions are called that because they're greater than 1 whole. And so in fifths, it would take 5 of them to make 1 whole. So 5/5 is 1 whole. So 5/5 becomes this 1. So what's left over between 5/5 and 6/5? 1, that's our remainder, and then our denominator still is there. So I told the kids I am perfectly fine with accepting this answer. That's fine. It's improper right now. We're not going to worry about it, but if the kids can realize how to do this, that's fine to let them put an or and put what it turned into as well. And that's fine. And I hope you guys have a great night. See you later.